Hello and thank you for joining us today. Today's topic is the new features of the brand new ConSteel 12. I am András Herboly, I am your host today, and today I'm joined by my colleague Roland Oka. Just for some practical information, control panel can be hid with the red arrow button, and question or messages can be sent with the chat options. Questions can be submitted at any time. At the end of the presentation, we will answer them. As usual, this webinar is being recorded and will be posted within 3 days on our website and YouTube channel. Just for a brief introduction, as you know, today content is focusing on the introduction of the main new features of ConSteel 12, the latest version of our structural analysis and design software, which was introduced a couple of weeks ago. Quickly about the agenda. At first, I will shortly introduce the system improvements of version 12. After that, I will highlight the new analysis features and capabilities. Then I will introduce the improved and complete fire design for steel members. We have new great tool to create reinforcement for concrete beams and columns. Furthermore, ConSteel 12 is able to evaluate the elements according to the Eurocode. Then my colleague Roland will show you the new documentation export to Microsoft Word. After that, the new joint tabs of CS joint connection module will be introduced. Then CSPI, ConSteel programming interface, new capabilities will be highlighted. And we will close with a QA section after that. Okay, so let's start with the multi-thread calculation and system improvements. So ConSteel 12 is able to utilize the capacity of the multi-core processors. Thanks to the new improvements, ConSteel uses multi-thread calculations for linear equation solver and eigenvector calculation. Furthermore, other optimization were also made. In overall, we can say that the analysis runtime expected to be two times faster than previously. Okay, so this is about the multi-thread calculation, and let's continue with the live demonstration. And let's see first the analysis improvement. So for analysis, we have two small result visualization improvements. The first one is the diagram view of the deformation. So in ConSteel 12, not just the contour surface visualization, but the diagram view is also available. So from the last drop-down menu, you can select the diagram view in case of deformation. In one hand, it is much more usable for documentation, but in the other hand, with this visualization, ConSteel 12 is able to show not just the deflection, but the rotation results also. You can see the rotation results on the structure. And the table result of the deformation was extended with one column. The last column contains the deformation from the warping. So this is a new result type. The other minor improvement is the long-awaited envelope result. So from the below the load combinations, you can find the envelope figures. We can select the result view, the envelope result view, both for ultimate limit state load combinations and serviceability limit state load combinations. So we can see in the minimum and the maximum values at the same time, or just the maximum or just the minimum. And if we're moving on the diagram in the graphical area, the result, the flag is not just showing us the values in the point, but the dominant load combinations also. And in the table result, also we have a new column for the load combinations, so we can see which load combinations caused the dominant values of the result. But there is an extra possibility in case of envelope result view. This is the user-defined envelope. So we can create several user-defined envelope result view, both for load combinations and both for load cases. If we have results for load cases also, now I have just load combinations. At the same time, we can use the ultimate limit state load combinations and the self-visibility load combinations if we want. And we can use all of the load combinations or just the selected load combinations, so we can switch on and switch off several load combinations from the envelope results if we want. Or the last option is to load combination based on selected load cases. It means that those load combinations will be included to the envelope diagram view where the selected load cases is in the load combinations. For example, in this case, those load combinations will be included to the envelope result where the permanent load is applied. And with the apply button, we can create this user-defined envelope diagram. But as I said, not just only one envelope user-defined visualization can be created, but several. Okay, so these are the minor, the two small analysis improvements. Let's see the major analysis improvements, which are connected to the buckling shape-based imperfection application. So the possibility of using buckling shape as an imperfection was available in the earlier version of ConSteel, but it was difficult to use, for example, for complex 3D structures, because the imperfection cannot be used universal for all of the load combination. But thanks to the new improvements of ConSteel 12, it automatically defines the proper direction of the imperfection in case of all of the load combinations, and apply accordingly. For example, if we would like to use a swaying buckling mode as an imperfection, now we can select and apply on the structure universally. Okay, so buckling mode can be selected in two ways. Just clicking somewhere on the graphical area with the right mouse button and selecting the apply eigenshape as imperfection option. So this is the first way. In this case, the value of the amplitude must be defined manually. The automatic calculation of amplitude based on the elastic critical buckling shape option is not available. But if we click on one of the member and click on the member with the right mouse button and select again the apply eigenshape as imperfection, in this case, this elastic critical buckling shape-based imperfection amplitude calculation is available based on the selected members. Of course, the result depends on the selected members, so it is suggested to select the proper one. Okay, so this is a new imperfection dialog. So let's see the new parameters. So of course, at first we can add a name for this imperfection case. The first option is the type of the imperfection. So we had two types of imperfection. The first one is the overall. In case of overall imperfection, the imperfection will be used for all of the load combinations, not just where the buckling mode was selected, but for all of the load combinations. So, for example, the swaying mode is a good example, which can be used for the whole structure. Okay, the next option is the modeling of the imperfection, which means which component of the buckling shape should be applied as an imperfection. In this case, we have again two options: the complete. In this case, not just the displacement, but the rotation also will be used as an imperfection on the structure. Another option is a light option. So this is, in this case, just the nodal displacement will be used as an imperfection on the structure. The next option is the sign of amplitude. In this case, we have two options again: the automatic and the manual. In case of automatic, ConSteel will be determined the sign of the amplitude automatically according to the load combinations. So the sign of the amplitude means the direction of the imperfection. So if you use the automatic options, ConSteel will be determined automatically the direction of the imperfection in all of the load combinations, and will be applied accordingly to the load combinations. In case of manual options, imperfection will be applied according to the buckling shape. For example, here you can see the buckling shape, or reverse if you set a negative amplitude value. So, for example, in this case, if I add the minus for the amplitude value, this buckling shape will be applied in the opposite direction. Now I'm selecting the automatic. Okay, the type of the amplitude and the value of the amplitude and the connected functionalities are the same as for in the earlier version of ConSteel. So we can set the amplitude with millimeter value or with a multiplication factor, and we can add the value of the amplitude manually, or we can use, as was shown previously, the two type of Eurocode determination. For example, this equivalent initial bow imperfection with the proper parameters, or we can calculate automatically based on the elastic critical buckling shape. Okay, so let's select the swaying mode as an overall imperfection, and let's define. Okay, and let's define another. For example, this one, which is a local imperfection, a local buckling of one of the column. And now I'm clicking with the right mouse button on the column and define the amplitude based on the elastic critical buckling shape. And now I'm using this imperfection as a local imperfection, because you can see it's not a global imperfection, it's a local imperfection, it's a local buckling of the column. And now I'm modeling as a complete imperfection, and I set the automatic sign of amplitude and determination. Okay. All the created imperfection can be seen on the Loads tab Global Imperfection menu. If you click on the application of eigenshape, so here you can see the two previously saved imperfection case. So here you can see the name, the load combination where it was saved, the used buckling eigenshape, the used member if we use the member way. You can see the type of the amplitude. So now I'm using the millimeter value, the value of the amplitude, the type. The first one is an overall, the second one is a local imperfection type, and we can see the modeling type and the sign option, of course. In the first column, you can find a checkbox with this checkbox, you can switch on and switch off from the global imperfection group one of the imperfection case, so it is not needed to delete one of the previously created imperfection cases if you would like to neglect from one of the calculation. So we just click on the first in the first column and using the checkbox option and switch off the not needed imperfection cases. Okay, and if you want to use the created imperfection group, you have to go to the Analysis tab and click on the Analysis parameter, and in the Global Setting field, you can select from the drop-down menu the created global imperfection group. Okay, and let's calculate again the model with these imperfections. Okay, so you can see the calculated imperfection, calculated results with global imperfection. So until now, the results of the imperfection application was a black box. We were not able to see the results only from the imperfection, but in ConSteel 12 we can do it now. So for example, if we select the load combination 101 and click on the third drop-down menu, we can find a new result group called imperfection combination. So this result contains all of the results from the imperfection which was applied in the selected load combinations. For example, in this case, in this load combinations, we have applied a global and overall imperfection, which is a swaying mode, and we applied a local imperfection from the buckling of the column. We can see the imperfection load which was applied on the structure based on the imperfection. If we switch on the visibility of the load, so of course, so it's kind of messy, but we can see in every finite element point the imperfection loads. Of course, I have applied, or I have used the complete modeling of buckling shape as imperfection, so that's why not just forces but bending moments also applied to modeling the rotation of the members. But not just the imperfection loads, but the deformations from the imperfection can be seen. So here you can see so the structure is moving in the x direction because of the swaying mode, and of course in the y direction because of the local buckling of the column. You can see the bending moments diagram, of course, and other imperfection, other internal forces also. So, for example, you can see the bending moments from the combined imperfections around the y axis, and you can see around the x axis. And of course, the other results, the deformations, the internal forces, and reaction forces, contains not just the effects of the imperfections, but all of the loads which are in the load combinations. So, for example, in this case, you can see this is the complete deformations from the loads and the imperfections also. Okay, but not just the imperfection combination results can be watched. If we want, we can run a second order analysis to calculate the buckling mode based imperfection load cases. If we switch on these options, we can see separately from the load combinations the imperfection cases. For example, this is the swaying mode. we can see the deformations, the positive deformations, and the calculated negative deformations, and also in case of local buckling of the column, you can see the positive and the negative deformations, and then so on. Okay, so this is the buckling shape-based imperfection calculation. The next topic is the complete fire design for steel members. For this, I will have to use more or less the same frame to introduce you the new functionalities. So in the earlier version of ConSteel, only the cross-section check was available for fire design situation. This functionality was improved with buckling analysis, including the proper buckling curve for fire design situation. Furthermore, the cross-section classification was also improved, and now ConSteel using the proper classification in case of fire design situation. Okay, so let's see how it is working. So let's go to the loads tab. For fire effect, a dedicated load group was created to handle the specialties of fire. So if you click on new load group and selecting the fire load group, we have two new options. The first one is to consider or not the indirect action of thermal expansion during the analysis. So with this checkbox, you can switch on and switch off the effect of the indirect action of the thermal expansion if you want, and we can select which variable factor should be used during the load combination generation. So we can use this option or that one. Now I'm creating a simple load cases in the fire load group, and now we can assign with the same fire effect and protection function and the final effect to the structure. So this fire effect and fire protection functionality is more or less the same as was in the earlier version of ConSteel. So we can set the fire curve. So we have the previously used three options: standard, external, and the hydrocarbon. We can set the period of time. So now I'm set the 30 minutes. We can set the fire protection. Of course, not just the protected definition must be set, but the unprotected also, because we have some extra settings for unprotected option also. So for example, in this case, I'm select the open eye section exposed to fire on all sides and applying this unprotected as a protection. And just with a simple click on the member, I assign the fire effect to the member. Okay, and if we are ready, the last step is to create a new accidental design situation load combination. Now in this case, just the permanent action is in the load combinations and the fire action considered in the load combination. Okay, let's run the analysis, not just for the normal load combinations, but for the accidental load combinations also, and calculating not just the first and the second analysis, but the buckling analysis also. Okay, and let's go further to the global checks, where we can see the utilizations and calculating not just the cross-section check and the buckling check according to the Eurocode in one step. Oh, sorry. And the last combination, which is the fire load combination, was neglected. If you run again, we can see utilization is higher than 100%, and if you see the most utilized cross-section, which is in the frame corner, the dominant examination is the global stability resistance, and if you click on the calculate section, you can see the details of the calculation, and if you see the parameters, you can see it is according to the fire code. So ConSteel using the proper parameters according to the fire code of the Eurocode, and you can see the global stability resistance in fire design situation. All of the parameters is available, but you can see not just the global stability resistance, but the pull resistance in compression. You can see the reduction factor, and you can see the temperature which is reached at the time which was set during the fire effect settings, and so on. We can see all of the parameters. So it's not adequate. Now the structure is not adequate, but if you go back to the load stub and modifying the protection from unprotected to, for example, a spray mineral fiber protection, and using 10 mm thickness from this protection and applying on this protection on the structure, and run again the calculation and go further to the global checktops and seeing the results. You can see that the structure is more or less adequate, and if you see the highest utilization point in the frame kernel again, you can see that the dominant load combination is the first one, so it's a normal ultimate limit state combination. So in this case, with the protection, the fire design situation is not the dominant anymore. And if you see the detailed result, ConSteel use automatically the normal parameters and the normal Eurocode 3 parts to examine the structure. Okay, and if we are interested in the temperature of the structure and the modified elastic modulus in the different points of the structure, you can go to the finite element tab, and if you select the fire load case, you can see in every point the used temperature and the modified elastic modulus in every point of the structure. Okay, so this is the new and improved fire design for steel elements. Let's go to the next topic, which is the reinforced concrete design for beams and columns. So in ConSteel, a handful of functionality were implemented to create reinforcement and make the design according to the Eurocode. So in ConSteel 12, reinforced concrete beams and columns with rectangular section, and in case of column, the circular section also available, can be evaluated. So here you can see a mixed material whole. So the column and the main girder are made from concrete section, and the secondary beams or trusses made from steel. So these sections are using the original reinforced concrete sections, which was available in the previous version of ConSteel. But to use this new functionality, we have implemented two dedicated cross sections. So at first we have to modify and use these new cross sections. So for this, we have to go to the structural member tab, and in the section administration, clicking on the macro section button and selecting the reinforced concrete field of group, you can see the available concrete sections. So the green ones are the original, the previously available sections. So these are also available, but these sections are not able to calculate it according to the Eurocode. You can use it, and we can put it in the global model, but these are not able to use to calculate the reinforcement. To calculate and design the reinforcement, we have to use these two dedicated macro sections, for beams, the rectangular sections, for columns, the rectangular and the solid circle sections. So let's create the new macro sections. At first, I create the section of the columns. So it is 500 millimeter width and 500 millimeter height. The material is C25, and I'm using the design value of the elastic modulus. And with the create button, you can create the new section. And let's create a section of the beam. Okay, so the width is 300 millimeter, and the height is 700 millimeter. The material is the same as in case of the columns, and I'm also using the design value of the elastic modulus. Okay, and let's modify the section with the select by property function. Now I select the section of the column, and in the property area you can modify the new sections. The color of the new section is different. So the original green color was modified to gray. And let's modify the section of the concrete beams also to the new cross sections. Okay. As a first step, I run again the calculation because of the new cross sections. Okay, it takes some time because second order and backing analysis is also performing, because I would like to calculate or design not just the concrete part but the steel parts for buckling also. Okay, so the analysis is ready. So let's go to the structural member tab, where we can find a new function called Rebar Editor. This Rebar Editor function is dedicated to create the reinforcement scheme for beam rebars and column for beams and columns. Every created reinforcement is connected to the selected cross sections, so it's not connected to the elements, but it's connected to the cross sections. And after we are ready, we can assign the created reinforcement scheme to several beam elements or several concrete elements with the same cross sections. Okay, so at first let's create the beam reinforcement. On the dialog we can set the material grade of the rebars. We can set the top, bottom and side covers. So now I'm setting 2.5 centimeters for covers. We can set the diameter of the stirrups, and we can set the strut inclinations. So this is the default value according to the Eurocode. We can modify between some limits, which is defined by the Eurocode. ConSteel is automatically check all of the parameters according to the Eurocode. Okay, and if all of the parameter is set, we can start in the editor field to add the rebars, adding the rebars. But if you would like to see the results to covering with the reinforcement, now we can save the reinforcement with the apply button, and we can set for several column. So in this case, the beams which was selected is highlighted, and the small symbol is added to the member. And if you go back to the Rebar Editor dialog, now not just the length of the member is loaded to the editor, but all of the design, all of the analysis result which is needed to add the rebars properly. Here you can see the load combinations. We can select one of them, or we can use the envelope view. We can see the results of the selected beams, or we can see the envelope results for all beams. Okay. With the plus button, we can add reinforcement. We can add to the bottom and to the top. You can add the number of the reinforcement. For example, at first, let's add 5 reinforcement with 25 millimeter diameter, and starting position is start at the 0 point, and the end position is at the 0 point. So it means the rebar will be uniform on the whole length. And here you can see, so this is the minimum value of the analysis result, and this is the maximum, and this is the bearing resistance of the member. So here you can see, so in the middle, in the midspan, the beam is not adequate. We can add some extra reinforcement. For example, from the start point, it's 2,000 millimeters, and from the end point, it's also 2,000 millimeters. And you can see it's also it's not adequate, but more or less now okay. And we will see. Let's go to the transfer race for reinforcement. Here you can see the shear results. We can set the stress spacing, and we can add from the whole length. So here you can see all of the calculated parameters. Okay, so it's not adequate again. In the first section, the last section of the member, let's add some extra stirrups. Okay, now it's adequate. And from the endpoint again, you can add some extra stirrup, and now you can see it's adequate. The shear diagram is fully covered with the resistance of the cross section. Okay, with the apply button, you can save the reinforcement shim for the selected beams. Okay, let's set the reinforcement for the columns also. So if you click on the Rebar Editor and selecting the column rebar settings, we can see the option. We have two main different reinforcement. The first one is which are in the
Muted. Unmuted.
So we can add some extra reinforcement on the side, on both sides of the section. So now I'm selecting the 25 millimeters and using
Muted. Unmuted.
I'm selecting 3 from the wide side and again 3 on the Z side, and we can select the distribution of the additional longitudinal reinforcement. It could be even, or we can set a start distance. So for example, let's set starting the first additional rebars from the corner with 60 millimeters from the main rebars. We have an extra options, the design parameters. So in case of columns, we have to set some design parameters. So for example, buckling loss coefficient around the Y and around the Z direction, or Z axis must be set it, because it is a cantilever column. I set the 2, but all of the other parameters will be calculated or automatically, or using the model parameters or model dimensions. Okay, with the apply button we can save it, and we can assign again for the members with just a simple click, or with Windows selecting. Okay. So I have created two reinforcement chain, one for the beams, which for added for concrete beam, and one for the column, the concrete columns, which were added for several columns. And let's see the detailed result. If you go to the global check, we can run the Eurocode calculations, both for the steel and both for the concrete parts of the structure, and we can select the beam reinforcement and the column reinforcement check separately. And if you click on the calculation button, you can see the dominant values of the utilizations in each point of the structure. Okay, and here is the result. So here you can see the utilization of the three structures and the utilization those concrete elements where reinforcement chain was assigned. From the drop-down menu, we can select just to see the results of the steel part if we want, or we can see just the concrete parts as well. Okay, the table results contains the dominant examinations in case of concrete results or concrete calculation also, such as in case of steel calculations. We can see the dominant load combinations, and if you click on one of the utilization point, even on the graphical area or in the table result, with the right mouse button, we can see in the cross-section module, we can see the detail of the calculation. So we can see the resistance of the longitudinal reinforcement, which is the dominant in this case. We can see the minimum longitudinal reinforcement, the maximum longitudinal reinforcement, and we can see the major of the major axis bending resistance, which is not adequate now. And we have note that the longitudinal reinforcement at tension is plastic, but we can see the shear resistance, the maximum distance of the stirrup is calculated or checked, the minimum percentage of shear reinforcement, and we can see the shear resistance in this case without shear reinforcement, because in this case shear stirrup or the reinforced concrete calculation is not needed, because the simple concrete cross-section is able to carry the shear force in this cross-section, and also the interaction between the shear and the torsion is also calculated, and it is noted that the longitudinal torsion reinforcement, additional longitudinal torsion reinforcement is not required. And if you see another point where the shear force is higher, sorry, it's the column. In this case, you can see the shear resistance, shear reinforcement is the dominant. And now we can see not just the shear resistance without shear reinforcement is calculated, because the simple concrete cross-section resistance is not enough to carry such a huge shear load, but the shear resistance with shear reinforcement, according to the selection, according to the settings, the applied stirrup distance is calculated, and all of the parameter can be seen. Okay, let's see the calculation of the column. So you can see, in this case, we can see not just the concrete cross-section, but the applied longitudinal reinforcement. You can see the interaction of compression and bending. The minimum diameter of the longitudinal reinforcement is calculated and checked. The minimum longitudinal reinforcement also. The maximum longitudinal reinforcement also checked. And of course, the interaction of compression and bending is also calculated. It is a slender column. Second order effect was taken into account according to the Eurocode. All of the parameter can be checked, which was used. And also the shear resistance of major and in major and minor axis is calculated. Okay, but not just the detail of the calculation can be seen, but we can see the resistance surface, of course. So here we can see, and we can see the points, the loading points with this red point, and all of the extreme values of the surface, resistance surface can be seen. Okay, so this was the new functions for reinforced concrete. Now I will hand it over to my colleague Roland, who will present the following topics about the new functionalities for sear joint module and the ConSteel programming interface.
Okay, thank you, András, for the presentation, and greetings for everyone. First, let me show you how the new documentation export function is working. From now on, from ConSteel 12, you are able to export your documentation to an editable Microsoft Word format. To show you this, I prepared a model, which you can see on the screen. I have pre-created a documentation, a statistical documentation, and I also attached to this documentation some joint documentations too. So I quickly open it. And I have added to this documentation some pictures, and there are also some diagrams in this documentation, and also, as I said, there is a joint documentation. Okay, to start the documentation export function, you have to go to this document icon here, click on it, and you will find an export to Microsoft Word option. If you select it, you will get this new dialog where you have to give the path of the exported file. So quickly let me set it to somewhere. And let's give a name to it. And you have one more option. You can use a default ConSteel template, which is basically included in the install package of ConSteel. And this template can be found in your install folders, data folder, and inside of that, at the export folder, you will find this consteel.x file. This is the file which contains all of the styling parameters which were used during the exportation process. So this is the default, but you can always create a copy of this file, add new stylings, add colors to it, add different text styles, and you can use that also if you choose to use your own custom template. Right now I will use the ConSteel default template, so if I click the OK button, the exportation process will started, and it may take a while because this documentation is quite long. It's about 200 pages, but after it finishes, we will see that a Microsoft Word file is created. Okay, so it says that the documentation export is finished. Let's check it out how it is look like. So here's the file, and if you open it, you have to do one thing. You have to update the fields to the content. After you've done this, you will also get your table content. Okay, and as you can see, the styling of this exported documentation is the same as was in the ConSteel. Pictures are exported as pictures. You can delete them. You can add more pictures. You can modify all of the data inside of this Word file. Okay, and also the joint documentation graphics are added to this Word documentation. Okay, so basically this is how it works. It's quite simple. The next thing I want to show is the new type of joints in ConSteel 12. We have two new type of joints. The first one can be found here. is the concrete column with steel bracing joint type, and the other one is the wall framing joint. So first let me show you the concrete column with steel bracing joint. This is basically the same as it was the simple bracing joint. So when you want to place bracings on steel beams, but there is one more option, one more connection type which we can select. So at the first dialog, as always, you have to select a concrete column section, which is now loaded into the model. This is it basically, and you can connect on 4 sides of it. First, let's connect to the right side of it. You can choose if you want to place a connection to the gusset plate upper edge, middle edge, or the lower edge. Let's place a connection on the middle edge. These 3 types of connections were already included in previous versions of ConSteel, but this is a new one. This is the front panel hollow section splice plate connection by the name, and you can use 2 types of hollow sections for it, and it can bear tension or compression forces. Okay, so if I click on the OK button and click on the Create button here, the joint will be created according to the default joint settings. And as you can see, this is the new type of joint. At the joint tree structure, you can see that we have a column section. We can choose the type of the column. We can choose if you want an intermediate connection or at the end of the column. We can add joint loadings as always, and this is the new parts because the plate on the concrete, which is highlighted with this yellow color. You can choose if you want to create a bolted plate, or you can embed it into the concrete column. If you choose bolted plate, you can choose the number of rows. You can modify the bolts and the material grade of the bolts. We have the connection plate, which is as the same as were in previous gusset plate connections. We can adjust the welds, which are basically automatically calculated, but you can adjust the plate and the weld thickness. And here we have several settings. For example, at the brace, you can choose if you want to rotate this section or not by 90 degrees. Here you can choose the section of this member. At the plates, you can choose that how do you want to connect this plate to the cat plate. So first you can choose if you want to place a bolted or welded connection, welded plate. Right now I will choose the bolted one, and in this case I can choose if I want to place one-sided or two-sided connection, and also I can choose this option, which will be kind of a splice plate. Okay, at the splice plate you can choose you can adjust the parameters of this splice plate, like the thickness, material grade. You can adjust the gap between the beam and the gusset plate. Also here you can add more bolt rows and bolt and you can add bolts, so you can adjust the horizontal and the vertical spacing of the bolt rows. And yeah, basically that's all. At the weld, you can adjust the welds on the cap plate, and you can adjust the weld between the splice plate and the cap plate. Okay, this is the first kind of new connection, and what is worth mentioning that this type of connection, so this cap plate connection can be also found in the steel bracing joints. So here you can also find the this new type of connection. Okay, the other new connection type is the wall framing joint. If you click on the next button, you will see that you have two options. The first is if you want to join to a concrete column connection, and the second is to a hollow section. Let's choose first the concrete column connection. The available section types shows you that, of course, you can only choose for the column a concrete section, which is loaded. And you can see that this connection will only bear shear forces. Let's choose a site for the connection. And here you can see that for this connection type, you will need a hollow section, and also you will need L profile, which is loaded already in the model. Okay, if you click on the Create button, this is how our joint will look like. So we have a concrete column, we have a plate on the column, we have the L section welded to the plate, and we have our hollow section bolted to the L section. Okay, and we can choose if you want to apply an embedded or a bolted plate on the concrete. We can modify the beam console, it's the L profile. We can basically change the section of it, and we can turn it with 90 degrees. Okay, we have the welds for this L section, and we have the wall header beam. Here we can change the section of it, and we can rotate it by 90 degrees again. And we have some connection options between the L profile and the beam section. We can add more bolt rows, and we can adjust the pitch of holes and the bolt parameters. Yeah, and if you improve the distance between the holes, the length of this L profile will be automatically adjusted. Okay, and this is how it works. Of course, if you create a joint by the model using this create joint by model function, it will work as the same as before. So ConSteel will offer you the possible connections which can be placed on this geometry. And if you place, if you want to place back on the model this joint, the joint update functions will also work on this new type of joint. So for example, I have a placed joint on this structure, and for some reason I change the cross-section of a connecting member. ConSteel will tell you that some kind of changes were performed on the model, and now the applied joint is not the same as the structure below it. So as you can see that right now the P1 joint is not same as the structure. ConSteel will select it, and if you want, you can update the joint model so it will refresh the joint, and if you open it up again, the new section will be loaded into the CS joint module. So these are the new type of joints. And the next thing I want to show you is the CSPI function, new CSPI functions in ConSteel 12. So during the development of ConSteel 12, in the CSPI developments had two main strands. The first strand was to improve the troubleshooting of your scripts, because in ConSteel 11, where the CSPI function was improved, it was a bit hard to find the mistakes in your code. So now we have a debug function, so-called debug function, which I will show you. And the other strand of the improvements was the improved modeling functions. So let me scroll through the new functions quickly, and I will show you in a live demonstration how they are working. So here you can find all of those improvements which were made. First of all, some minor changes that from now on you can open Excel files with relative path, not only absolutely given path. We have added new macro sections. So right now you are able to create all of these compound macro sections from CSPI, not only the welded from plates type of macro sections and the cold form or hot rolled macro sections. Next, we have added some new modeling functions, which are, for example, that was a problem that you couldn't delete elements from the model through CSPI. So there are two new delete functions which will basically clear all of the stuff from your model. We have some selecting options, so you can select everything in your model, you can deselect everything in your model, you can invert selections, you can select members by their IDs and deselect them also. You can select items by their types. So for example, you can select them if you want you want to select all of the structural members, so you want to select all of the point supports and so on. You can also select by the user. So if you choose this, the user will be asked to select manually those elements which he wants to modify later. And we have some action modeling functions, so we can move the selected items in the model, we can copy them, we can rotate them, we can rotate and copy them, and we can mirror and copy them. So these are the new modeling functions, and the last bunch of functions is the user input functions. These are basically with this get user input functions, you are able to create dynamic windows. And on these dynamic windows, you are able to ask the user to give input parameters. So in this way, the user don't need to scroll through the script and search for a variable and redefine them. You will give them a nice dynamic dialog and you will ask them to give some parameters. So let me show you how are these new functions are working in action. And for this I will open a new model. And first I will show you the debug function and the new troubleshooting functions in ConSteel 12. Okay, so to be able to find your mistakes in the code, we have implemented an automatic code check for the editor. That means that if you type something in the editor, and if it's not a valid command or not a valid script, ConSteel will throw you a red error message that this is an unknown command. For example, I didn't finish the variable definition. And also this code check is performed on every command, and it tries to tell you that what is the problem. So for example, if I type a create command and I make a mistake, for example, I didn't load the section, this section, it will say that this section could not be found, so the code cannot be performed. So this is this auto code check is always running in the background, and if I add a load section command, the messages will disappear. Also, if for some reason I make a mistake and this member should be a zero length member, ConSteel will tell us that This is a zero-element member, so it cannot be created. Okay, so this is the automatic code check. It helps you to find the mistakes before you run the code. And the other one is the debug function, which will help you find mistakes after you run the code and after you realize that there are some problems. And for this, I will load a pre-made script. And as you may notice, there are some changes on the CSPI editor. You will have a watch window on the left side, right side of the editor, and we have some controls here for the debug function. What debug does is with the debug function you can stop the code at any places after you initiated the debug function. So let's say I will add a debug point and I want to stop the code here when I will run it. And let's see, and of course I can create and add more debug points, and let's see how the debug works. So with this button you can add debug points, and after you add it you can delete it, or you can delete all of the debug points at one click. Okay, so if we have added debug points, we can initiate the debug function with this button, and after you press it, debug function will be activated, and right now you see that the number 5 line is highlighted with this gray color, and it says that s equals a question mark, so it means that in this line the variable definition will take place. If I go one line further, go to the next row button, s equals 15,000 will be showed here. And also in the watch window you will see that this s parameter is added. If I go to the next row, all of those parameters which are defined will be listed in the watch window, and we can follow up these variables and see that what are the content of them. Okay, and let's jump to the next debug point with this next button, because I have placed one more debug point at the 98th row line. And here, if I go to the next row, we will arrive to a fourth cycle. And as you can see, the running parameter, which is the end parameter, is right now under definition. So right now we don't have a value, but it will get the 0 value. And the end parameter for the fourth cycle is the 4. So it means we will perform this fourth cycle 4 times. Okay, we have reached an if statement. And as you can see, these are the statements. So if this statement is true, we will step inside this if statement, which is now the case because this is smaller than the BL parameter. Okay, and from row to row we can step through the code, and as you can see we have reached the end of the cycle. We stepped back to the first line of the fourth cycle. Right now the n is increased by 1 because this is the second run of the cycle, and if we go again we can cycle through the cycle. So right now the n is 2, so this is the third run of the cycle. So this way you can get a picture about what your code is doing, and maybe it can give a better understanding of your code and you can find problems more easily. So this is the debug function. The next thing I want to talk about is the dynamic window and the modeling functions of the new ConSteel. So for this I will again create a new model, and I have pre-created a script, an example script which I will show you. Okay, so basically with the get user input command, we are able to ask the user to add input parameters or make decisions during the run of the code on these dynamic dialogues. So if I click on the run button, we will get this dialog. I have added to this dialog some checkboxes and in this case one drop-down menu. So here the user can decide if he wants to delete previously placed structures or not. Right now we don't have any, so it's pointless to click it. We can copy elements if we want to. In this case we have to click on this button checkbox, or if we want to mirror something we can also click on this button. From the drop-down menu I have to the drop-down menu I have added some structures in the code. So right now we are able to create a frame with this script. For example, so I select the frame option and I click OK button. We will receive a new dynamic dialog where we will ask to give the span of the frame to be created. So let's say this is 10,000 millimeters wide. The height of the column, let's say it is 4,000 millimeter, and the height is 5,000 millimeters. We can set in this case the purlin supports distance between the purlin supports. Let's say it is 800 millimeters. We have a decision to place lower flange supports or not, and also we can ask the user to select the insertion point of the left column of the frame. Of course, any kind of parameters can be asked from the user. Right now I have chosen only these few, and if I click on the OK button, the frame will be created according to the settings. Okay, and if I run the code again, let's say I want to delete everything from the model, so delete previously placed structures. I will click on the OK, I will click the checkbox on and click OK. The content will be deleted, and let me show you the next example, which will be a block, kind of a block structure. So let's click OK. We will receive a new dialog which asks that if we have a connecting structure or not. In this case we don't have, because this is the first one. So let's click OK, and we will get this new dialog which I have made it, where I can choose the material grade of the structure to be generated. We can choose the section of the beams, the columns. We can choose if you want to place bracing on the structure or not. Let's choose that we want to. We can add the height of the columns. We can give the span in X direction. Let's say it is 5,000 and 6,000 in Y direction. We can select the insertion point, and also we can choose if you want to place supports on the end of the columns or not, and what kind of supports do we want to place. Okay, and if we click on the OK button, because on the previous dialog I have selected that I want to place bracing, I can choose that what kind of section do I want to use for the bracing, and on which side do I want to apply. Let's say that I want to apply on the negative X side and on the negative Y side. And if I click OK, the structure will be generated. And if I want to, I can run this process as long as I want. So at the next phase, I will have a connecting block at the -Y direction. And again, I can set the parameters, input parameters. And again, I can define that on which side do I want to place the bracings. Okay, for some reason I think the span was given falsely, but never mind. You get the point. You can create as many structures as you want with this function, and also if I want to copy the my generated structure, let's say I want to copy it, I will click on this checkbox, and if I click OK, I can get the base point of the copy, and I will select this lower point of the column and the insertion point of the copied elements. Also, I will give some points, for example, the upper part of the column, and if I click OK, I have to select the objects which I want to copy. And as you can see right now, there are 22 selected objects, and if I click on the OK button, the program will copy the selected members. Next one is another modeling function, is the mirror function. So if I choose to mirror, I have to give that what is the mirroring plane. So I have to select the first point of the mirroring plane. Let's say it will be this one, and the second point of it will be this one. And I have to choose that which are those members which I want to mirror. Yeah, you always have to click on the select button first, and then you can select the objects you want to mirror. And if you click on the OK button, the structure will be mirrored to that mirroring plane. Of course, any kind of parameters can be asked to given by the user, not only these one, loadings, load groups, and all of those parameters can be asked, which can be found on our wiki page on wiki.consteelsoftware.com. Okay, so this was the new CSPI functions, and yeah, this is all what I wanted to show you, and I will give back the speech to my colleague András, and he will share you some useful information for the future. Thank you for your attention.
Okay, Roland, thank you for your presentation. It was a very great demonstration. Okay, so for now we are done with our presentation. I would like to thank everyone to attending our today webinar. I hope you have enjoyed and learned in this presentation. So thank you very much and goodbye.